Hello and welcome to Astronomy Daily, the podcast that brings you the universe one story at a time. I'm Avery.
And I'm Anna. It's great to have you with us. We've got a packed show for you today, Avery. We're talking about a massive expansion for SpaceX launches, a new theory that could double the age of the universe, and a potential glimpse of a primordial black hole, and an interstellar visitor heading for Mars.
An absolutely fascinating lineup. So where do you want to start? Should we kick things off with the launch pad?
Let's do it. Our first story is big news for the pace of space exploration. SpaceX has just received a green light from U.S. regulators to more than double their launch rate from Florida.
And when you say more than double, you really mean it. They're going from 50 Falcon 9 launches per year up to 120 from Cape Canaveral. That is a staggering increase in frequency.
It really is. And to handle all those returning boosters, the approval also includes a new on-site landing zone. They're planning for up to 34 booster landings right there at the Cape. This is all about streamlining their operations.
So how does an approval like this work? I imagine launching that many rockets has some environmental considerations.
Absolutely. The approval is officially called a mitigated finding of no significant impact. That means they've put measures in place to protect local wildlife and the environment, but it's not the final step. SpaceX still needs a final license modification from the FAA and approval from the Air Force before they can start ramping up.
It sounds like they're clearing the final hurdles. This has to be a huge relief for a lot of companies and agencies. We've heard about the launch bottleneck for a while now. This should really help ease the traffic jam for commercial satellites, military missions, and of course, SpaceX's own Starlink constellation.
Exactly. And this isn't just happening in Florida. They're planning a similar expansion for their West Coast operations at Vandenberg Space Force Base in California. We are truly entering an era of unprecedented access to space.
Beyond just easing the traffic jam, what does this increased capacity mean for the kinds of missions we'll see? Are we talking more science, more commercial activity, or both? Well, I guess we'll have to wait and see what happens in practice, but I think you'll find it'll be a balance of both science and commercial. All right, from the very practical to the deeply theoretical. Anna, our next story is a real mind-bender. A new study is suggesting that dark matter doesn't exist and that the universe is twice as old as we thought?
That's the headline, and it's as provocative as it sounds. A physicist named Rajendra Gupta has proposed a new cosmological model that attempts to explain the universe without the need for dark matter or dark energy, which are foundational pillars of our current understanding.
Okay, I'm intrigued. How does he propose to do that? Our current model relies on dark matter to explain why galaxies don't fly apart.
Well, Gupta's model combines two different and somewhat controversial ideas. The first is called covarying coupling constants, or CCC. This theory suggests that the fundamental physical constants of nature, things like the strength of gravity, might actually change over cosmic time.
Whoa, that alone would rewrite the textbooks. And what's the second idea?
The second is an old hypothesis called tired light. This idea proposes that light particles, photons, lose energy as they travel over billions of light years. This energy loss would cause their light to shift toward the red end of the spectrum, which is something we currently attribute almost entirely to the expansion of the universe.
So by combining these two theories, he can explain cosmic observations without dark matter. And how does that lead to the universe being twice as old?
By reinterpreting the redshift of distant galaxies, his calculations suggest that the universe isn't 13.8 billion years old, but actually 26.7 billion years old. It completely changes the timeline of cosmic evolution.
This is a monumental claim. Dark matter is thought to make up about 27% of the universe. To just remove it from the equation is a radical step. So, what's the next step for this theory? How do we know if it holds any water?
That's the key question. The model now has to be rigorously tested against real-world observational data. Can it accurately predict the rotation speeds of galaxies? Can it explain the patterns we see in the cosmic microwave background, the afterglow of the Big Bang? The standard model does this very well, so Gupta's theory has a very high bar to clear. It's a fascinating alternative, but for now, the standard model remains the reigning champion.
Speaking of cosmic mysteries, our next story comes from the James Webb Space Telescope, which may have just found the first direct evidence of a primordial black hole.
This is an amazing story. Astronomers were looking at an object nicknamed the Little Red Dot, officially called QS01, and this little dot might just be a massive black hole seed born in the fiery chaos of the very early universe.
How early are we talking?
The light from this object comes from the epoch of reionization, just 600 million years after the Big Bang. That's incredibly early in cosmic history. And the black hole itself is estimated to have a mass of 50 million suns.
50 million solar masses, less than 1 billion years into the universe's existence? That's a monster. How were they even able to see something so distant and ancient?
They had a little help from Einstein. The observation was made possible by gravitational lensing, where the gravity of a massive galaxy cluster in the foreground acted like a cosmic magnifying glass, amplifying the light from the little red dot behind it.
So what makes this discovery so significant? What does it tell us about how black holes form?
Here's the most fascinating part. This enormous black hole is located in a surprisingly small host galaxy. According to our current models, galaxies and their central black holes are supposed to grow up together, but this black hole is way too big for its galaxy. It's like finding a giant skeleton inside a child's playroom.
Which suggests the black hole came first?
Exactly. This could be evidence for what are called heavy seeds. Instead of forming from a collapsed star and slowly growing, these black holes might have formed directly from the collapse of massive gas clouds or even from density fluctuations right after the Big Bang itself. These would be true primordial black holes.
It's an incredible find. I assume there's a caveat here.
Of course. The findings are currently in a preprint, which means they're awaiting the rigorous process of peer review. But if they hold up, this little red dot could fundamentally change our understanding of how the first galaxies and the giants within them came to be.
All right, for our final story today, we're coming back into our own solar system, but we're tracking a visitor from very, very far away. An interstellar comet is set to make a close flyby of Mars.
That's right, Avery. The comet is designated 3I Atlas, with the I standing for interstellar. And on October 3rd, 2025, it's going to pass within 18.6 million miles of the red planet. That's a fantastic observation opportunity for our robotic explorers there.
And it sounds like the European Space Agency is already getting its probes ready. What's the plan?
ESA's Mars Express and Trace Gas Orbiter are going to attempt to observe it as it passes. They'll try to image the comet, though it will still be quite distant for detailed close-ups. More importantly, they'll use their spectrometers to measure the light coming from it, which can tell us about its chemical composition.
So we get a chance to analyze the building blocks of another solar system? That's incredible. Are any other spacecraft going to be looking?
It's very likely. NASA's orbiters like MAVEN and the Mars Reconnaissance Orbiter, and perhaps even China's Tianwen-1, could all potentially point their instruments at the comet. Even the JWST has already taken a look at 3I Atlas from its vantage point further out in space. It's an all-hands-on-deck effort to study this rare traveler.
It's amazing to think that we have a fleet of advanced scientific instruments orbiting another planet ready to welcome a visitor from the stars. October 2025 is a date to mark on the calendar.
And that's a wrap on today's astronomical news. We've gone from the bustling launch pads of Florida to the very edge of cosmological theory, deep into the cosmic dawn, and back to a close encounter at Mars.
What a journey. A big thank you to all of you for tuning in and sharing it with us. And for even more news, please visit our website at astronomydaily.io, where you'll find our continually updated newsfeed, plus all our back episodes if you need to do some catching up. Until next time, this has been Astronomy Daily. I'm Avery.
And I'm Anna. Keep looking up.